Today's lesson is on parallel and perpendicular line equations. So we're going to look at how to use slope to partition directed line segments. We're going to identify parallel and perpendicular lines. We're going to write equations of parallel and perpendicular lines and use slope to find distance from a point to a line. Our two main theorems are Theorem 3.13, which says that two parallel lines have the same slope, and slopes of perpendicular lines have a product of -1, or you can think of it as they are opposite reciprocals of each other. So in other words, if one is 5/3, the other would be -3/5. We'll start with our first example. Find the coordinates of F along a directed segment so the ratio of CF to FD is 3 to 5. So the first thing you're going to do is add 3 plus 5, which is 8. So we're going to figure out what fraction this is. So 3/8 is our fraction we're going to be working with. Next we're going to do rise over run. So that would be -3 minus 5 over 8 minus -4, which is -8/12. Do not simplify that. To get our answer, we're going to take the values for the rise over run. So remember, the run is the x, so we're going to take our fraction, 3/8, multiply that by 12, which was the run part of that. That would be 36/8, which is 4.5. Then we're going to take 3/8 of the -8. That's the rise part, which will equal -3. We're going to take our values for the point C, so -4. We're going to add 4/5 to that, or sorry, 4.5, and then we're going to take our other coordinate, which for point C, the y was 5, and we're going to subtract 3 or add -3 to that. So we're now at 0.52, and that would be our answer. In our next example, determine which of the lines are parallel and which ones are perpendicular. So simply going to look at slopes and compare the slopes of each of the lines to figure out our answer. So we just use rise over run, or y2 minus y1 divided by x2 minus x1 for each of the lines to determine whether they are parallel or perpendicular. So if we focus on our different lines, we have 4 different lines, A, B, C, and D. We'll start with A. Slope is -2 minus 4 divided by -2 minus -4, or plus 4, which would be -6/2, which we know is -3. B, (1 minus 7) divided by 7 minus 5, which equals -6/2, which equals -3. Line C has a slope of 1 minus 4 divided by -3 minus 6, which equals -3/9, which equals 1/3. Line D negative 7 minus 2 over 0 minus 8, which equals negative 9 over negative 8. Now we're looking for same slopes. So A is parallel to B. They have the same slope. We're looking for slopes that are opposite reciprocals. That would mean A is perpendicular to C and B is perpendicular to C. In our next example, we're going to write an equation of a line going through the point negative 4, 6 that is parallel to the line. Y equals 3x minus 4. We look for the slope of the original line, 3. Slope of a line parallel is the same slope, 3. We're going to use y equals mx plus b. We're going to plug in the point for x and y, 6, and find our new b, equals 3 times negative 4 plus b. 3 times negative 4 is negative 12. Add 12 to both sides. So b equals 18. My new equation, I'll fill in the new slope, which is the same as the last one, and my new b value. Here's my equation of my line. Write an equation of a line passing through the point negative 12, 6 perpendicular to the line y equals 2/3 x minus 10. So my new slope, here's my original, is the opposite reciprocal. That would be negative 3 over 2. I'm going to again use the point and the slope to get my new b value first. 6 equals negative 3 over 2 times x, which is negative 12, plus b. 6 equals, this would be 36 divided by 2, 18 plus b. Subtract 18 from both sides. Negative 12 equals b. My new equation would be y equals negative 3 over 2x minus 12. So you want to find the new y-intercept, which is your b value, first using the slope for the correct line you're finding. Parallel, remember, same slope, perpendicular, opposite, reciprocal slope. For our last example, we're going to find the distance from the point 6, 2 to the line y equals 2x minus 4. Okay, so the first thing we're going to do is look at what is the slope of a line perpendicular to the line that's given. So my slope would be, slope over perpendicular would be negative 1/2. Opposite reciprocal of 2 over 1 is negative 1 over 2. Next, I'm going to use this slope and the point to get an equation of my line. So that would be negative 2 equals negative 1/2 times 6 plus b. Half of 6 is 3, so it'll be negative 3. On the left is negative 2. On the right, negative 3 plus b. Add 3 to both sides. b equals 1. So my new equation is y equals negative 1/2 x plus 1. Next, I want to find the intersection of the lines to figure out where that point is. Then I'll be able to use my point to get the distance and the other point to get the distance using the distance formula. Couple steps here in solving total. So my new equation in this equation, I want to find where those lines intersect. So to do that, I'm going to take and solve and replace. There's a couple ways you can do this. I think an easy way to do this, a little different than what the book shows, since y equals both of these, is set them equal to each other. So that's really what we're figuring out, is where do they equal each other? And solve that. Since we've practiced these in class, we should be able to solve these fairly quickly. I'm going to add a half x to both sides, or 0.5 x. So that'll be 2.5 or 2.5x. I'm going to add 4 to both sides. Equals 5. So 5 divided by 2.5, which may not be the easiest decimal-wise, but if you think of it, 2.5, I'm going to go up here and write this. 2.5 is 5 halves, so this is the same as 5 halves. 5 divided by 5 halves is the same as 5 times 2/5, so that equals 2. So x equals 2. Once I have the x, I'm going to go back to the original y equals 2x minus 4. 2 times 2 is 4, minus 4 is 0, so that's y equals 0. So my point is at 2, 0. So now I'm going to find the distance from 6, negative 2 to the point 2, 0 using distance. So just put it into the distance formula. Same thing we've been practicing. So I have y2 minus y1, 0 minus negative 2, or plus 2 squared, plus the x2 minus x1 squared, so 2 minus 6 squared. I have 2 squared is 4, plus negative 4 squared is 16, which equals the square root of 20, or approximately 4.5. So this one, again, to review our steps, we found the slope of the line perpendicular, then, so this was the first step. Next we wrote our equation of our new line. So this was our second step. We found the b and then wrote our equation. Then we took and set the two equations equal to each other, found the x, plugged the x back into the original equation to solve for y, and finally used our points 6, negative 2, and 2, 0 to figure out our distance formula to get the distance from the point to the line. That's it for our lesson today.